Hello and welcome to this generics part 2 video. Now if you haven't seen the previous video that I made, we talked about associated types. You could go and watch that video, but if you have watched it, then yeah, we're just going to continue with it. Otherwise, what I said, we're going to implement this entity store now, and that's exactly what we're going to do. So with that said, let's just go straight into it. So let's start by trying to spell struct correctly, and we're just going to say container first of all, and we're going to implement it without the generics first, and then we're going to add the generics afterwards. Okay, so we have to have a property of int, right? And we're going to need some items, get item, remove item, update item. So we're going to need some items first of all, and this is going to be private. We don't want anything being able to access these, all right? And we're just going to say, we're going to call it an item, right? And what we're going to do in here is we're going to say a type alias is equal to, let's call it integer first of all. And then we're going to start it with this, and we're just going to say the items first of all is going to be created like this and so on, and then the count is going to be a computable, and it's going to say items dot count. All right, so it's compiling perfectly fine. Now we've only used the type alias. That's nothing to do with genetics when we use type aliases. However, they work well with associated types as well. All right, so right now we've added the item, we've added the counts, which we've got here, and now we have the items that can work inside to be able to assist us to implement these functions here. So next we can say get item, and we want an ID, and we want to know that the t.id. So we need to say that this item needs to implement identifiable. All right, so but let's just put this as item first of all, and it needs to throw as well and return an item. All right, and next thing we've got is the function get items, and this returns an array of items as well, and we can implement this straight away. Is then just items, and then the next thing then is mutating, and we're going to say function remove, and then ID is then going to be string for the time being, and this then going to throws as well, and we can turn around and say items dot remove where, but realistically speaking, I'd much prefer to say it this way and say items index at first index where, and then we're just going to use it like this, and then say we need an ID here is equal to then ID. Obviously we don't have that implementation, so it's going to be a problem, and now we can say items remove at index here. Yes, we're going to get problems, and this would be if it doesn't throws in the else as well. And the next one we've got is mutating function updates, and we have then the ID. Let's just do string for the time being, and item is then here, and this then throws 2, and it's going to return an item. So the update, we can copy and paste this once again, and from here we can literally turn around and say then index is equal to item. All right, and now we've got that. Let's just move that out way again, and so now we have get item. So we want to be able to get the item first of all. Well, we can do this like this, and then basically return. Yeah, let's just do it like this first of all. We can say item. There's a cleaner way to do it than this, and otherwise we're gonna throws here and so on. But we've still got some problems here right now because we don't have ID. All right, and this is where it gets tricky for some people. So now we want to make the container implement entity store, and let's see how far we get with this now. And we can say container does not conform to identity protocol. Well, that's because integer doesn't conform to identifiable. So let's just make integer conform to identifiable first of all, and we'll say let's look at what identifiable requires. Well, that has an associated type as well, and that says that the ID needs to be hashable. So it's saying var ID self ID here, this has to be hashable. Well, we know that a string is hashable, so we can say here var ID here is string because string is hashable, and then we can just say hash value here right now, and it needs to be public as well. And we can run this, cannot convert, oh yeah, sorry, here we can just do this, and then that now makes integer an identifiable, because the hash value is always going to be unique based upon that one integer itself. So next we want to add the stubs, and we can see that the add function we didn't do, so items.append item, and let's come here and say item instead. And get item, as you can see here, it didn't like that, because we said get item was here with string, but we can say here still item.id, that's no problem. And now we can cut and paste this and bring it down here and bring this like that, and so on. And then if it doesn't exist, then we could throw something here. All right. Otherwise, we have two implementations of get item now, so remove that, and let's just leave this for the time being, and update is item dot here. And we can run this, and the only thing that we are missing here is then we can return the item. Okay, so and now just to fix this throws, we're just going to implement a very, very simple enum here, and we're going to say container error, and this is going to implement error, and we're just going to say case item, or we'll just say not found, and this can be a string as well. So we're going to say throw container error and then not found. All right, so that fixes this problem, and then if it doesn't find it there, we can throw item not found either. And so let's just remove this now and remove this side. Let's have a look. So let's move the add down here, and let's clean it up. So we've got create is here, read is there, and now we want just to clean it up here, and we'll put updates, and then we have delete. So there's ways and means of cleaning this up to make it look that little bit nicer, but I'm happy with it enough. So let's walk and talk through this now, right? We have the entity store that had the associated type, and we have now added a type alias for that one associated type of type T, right? This type T then comes down to the items, and then the item here, and then the ID here as well. So we've used all of these, we've implemented all of these, and we've added so we can change that to be here as well. We've basically removed all of the implementation or the concrete type up to this type alias here. Now, as I've said in the previous video, we can remove this one requirement here to the struct level, and we can say here, as long as this T implements identifiable, it's perfectly fine. Okay, first things first, we need to fix everything where it says integer. Make sure that they have all gone, and when we recompile this, you see that the compiler was getting confused because we said that the T needs to be identifiable here. We set the type alias, but because the integer was still declared here, that the connection between the generics and also the associated types and type aliases was was broken. But once we added the item to here, the compiler could work out, okay, we're all conforming to this type alias and the associated type, so everything is perfectly fine. So let's come and now use it, and we can say container here and items, and if we then say, for example, hello, and now compile it, you can see generic struct container requires string conform to identifiable. Well, we can fix this by making the string also conform to identifiable. So it doesn't, as long as the collection conforms to identifiable, or the item in it conforms to identifiable, then we're perfectly fine. So we have to say public on this var ID, and we're going to say string, and we're just going to return self basically here, and now it can be identified by itself, which means now that the container's generic type alias stroke associated type is now of string. So you can always have as many different types as you want, and it's called container one. And now we can make our own. Container item, for example. Container item, and this can be identifiable, and this is just then got to have a string, right? And then that's it. And when we come here, now we can create an array of container item, and this is then going to be 1. And you can see here now we have a container from container items, because container item conforms to or implements identifiable. When we take that away, you can see generic struct container requires container items conform to identifiable. So let's just remove that, or to undo that and take it back again. So you can see this is the power now, how we can write a generic protocol that can be passed on that allows some form of concrete implementation to abide by the same rules for that one's type. And it also allows you, when you've got a database entity and they are indexed by a string, or in this sense by a string, because we're saying here that it needs to be hashable at least, but it doesn't necessarily hashable. An integer is also hashable, so we could say that this could be also an integer as well, right? So you could use an integer, you use a string, and so on. So here we can identify each item within inside of the database, and we can update them, we can remove them, we can get all of them, we can filter through them, we can do whatever based upon the least amount of information that we need to know. We don't need to know about all of the other items, because the whole point here is that an entity store knows how in the background, let's go and have a look at this, knows in the background with the add here, this is the database knows how to deal with this, to deal with this, okay? And it knows how to add them. And as long as your internal container knows how to deal with these items, then it's fine. But that's nothing. This is not saying that you just have to support identifiable. It could be that you want to also save some form of JSON data in your database or on a file system, and so on. And you could also add here that it has to be codable, all right? And when we come down the bottom, you can see that it starts getting a little bit messed up, right? But however, we can come in here and we can say, hey, you've got to implement codable and identifiable, and you can see now that our container item is allowed to go inside of it. So when it comes down to adding items, you now know that item can be converted to JSON, or it can be decoded, encoded in whichever way you want. So when you say get items, you could go to the file system that could be JSON, and then you could then convert it to a type and then return it as well. So, but there's a whole bunch more things and reasons why generics, especially associated types, really assist you in working with different data types, and that's why it's always good to use an entity store for this, because a database tends to have lots of tables, and every single table predominantly is an entity. And when you're extracting that data, you want to know that you've got one store that can work with every table in the database, and without having to have multiple implementations of it. You just need to concentrate on the usages of it instead. With that said, I hope that you've got something out of this one video. If you haven't understood it fully yet, don't worry about it. It says it takes a little bit of time, and I am an experienced developer, and I've worked with generics inside and out. Now, the most important thing that I can say to you is try to use generics associated types carefully. Okay, you don't want to flood your data. You don't want to flood your application with generic associated types. My advice from experience is that if you have a database, this is how it's stored. You know, this is the raw type of the data inside of the actual database, be it an SQL or whatever. It doesn't matter. It's its raw form. And when you extract it out, okay, this would be then concrete types here, such as structs. We haven't talked about classes right now, but these are pure implementations. So this should not be protocols. All right, should not be protocols at this level. But then when you pass it on to, like, say, the views or a view or something like that, that shouldn't be allowed to know about the implementation. They just need to know about how to receive the data. This is where you should start using protocols, right? So at a view level, you should, if you're passing data to a view, you should be giving it as a protocol, as immutable as possible and as minimal implementation as possible. However, when an action in a view, right, an action in the view happens and you're sending that data onto a view model or something like that, then my advice here is to use DTOs, okay, data transport objects. And data transport objects, predominantly, you should always try to use structs because they're immutable. So you transfer a struct that doesn't need any protocols, anything like that, to a service stroke store, right, that can pass this onto an actual store, right? So inside this arrow here is where the converting of the DTO, right, is then converted to the entity that the store actually needs. Okay, so this is really where the change happens. The view should know it really at a DTO level, right, for the actions, but when it receives it, it should know what it should look like and how to send it on even further to the likes back to the view model to create. But a view should come with its own DTO, data transfer object, to know how to create it. So these two really, they all sit together. The ownership of the DTO should be at the view level or at the service level at least. But if the view knows about the view model knows about the DTO, then the three of them should all sit together and so on. But the service should know in the background about the protocol and about how to pass the data on. So be very, very careful, very careful that you don't pass information from the store level all the way down to the view level, because this view wants to be as dumb as possible, right? And if it knows about stuff at the store level, then it's too intelligent, all right? So this DTO is a good way of separating straight down the middle, and that's why try to pass just DTOs on further here and have some form of conversion within inside of a view model to tell the view, hey, here's the information that you need, and that's all you need to do. And any actions, let me know about the actions, and I'll do the converting back to send it up even higher. It's another level of abstraction. Okay, so try not to use, what I'm trying to say is try not to use type aliases and or associated types at a view level. All right, use structs and DTOs. That's it, and use view models and actions to pass them upwards too, because you add so much more complexity by adding associated types when you come down to the view level, and try and remove it from that one level. All right, now it might look all super clean, super tidy, but I can promise you, if you change some form of part of the architecture, some form of the entity, how it is, you'll break everything and you'll spend more hours changing it to work again. Whereas just keep the views as compact as possible, as modular as possible, and as dumb as possible, and you will save time, right? And it means you can create a brand new view using the DTO, and it's the only thing that you need to worry about is the DTO, and that is the only thing that you need to update. All right. With that said, maybe that was just a different video in itself, what I was talking about, but that really requires another example. So maybe the next video will be an example for that. With that said, thank you very much for watching. I hope you've got something out of this one video. I definitely hope you've learned something from this one video. And if you haven't, then just rewatch it again or watch the next video, which will probably help you even more. I hope so. Otherwise, don't forget to like, subscribe, share, do all of the other social media things that could be done with this one video. If you've got any questions, feedback, concerns, let's start a conversation in the comment section down below. Other than that, my name is David Thorne. Thank you very much for watching, and I'll see you in the next video. Ciao, ciao, and goodbye.